Hello and welcome to part 1 of my practice test 2 for statistics. My first question on here, I have researchers want to determine if having a high quality sound system in the bedroom is associated with obesity. The researchers administered a questionnaire to 362 12-year-old adolescents. After analyzing the results, the researchers determined that the body mass index of the adolescents with a high-quality sound system in their bedrooms was significantly higher than that of the adolescents who did not have a high-quality sound system in their bedroom. And I ask, can the researchers conclude that a high-quality sound system in the bedroom causes a higher body mass index? So, and then why or why not? So the answer to that's going to be a no. And the reason why is this scenario. This scenario describes an observational study. Observational study. Not an experiment. So because of that, they can only claim an association. All right, on to the second question. So a student at a junior college surveyed 20 randomly selected full-time students to determine the relationship between the number of hours of video game playing each week, X, and the grade point average, Y. She found that a linear relationship exists between the two variables, and the least squares regression line that describes this relation is y hat is equal to negative 0.066 times x plus 3.457. And for part A, we want to interpret this slope. So, on average, the grade point average decreases because it's negative by 0.066 points for each additional hour of video game playing each week. Connected to that, part B wants to interpret the y-intercept, right? Now, I didn't give you any data, so I mean, you can't see if any data points are near 0, but if someone doesn't play any video games, a GPA of 3.457, there's certainly no issue with that. So this is definitely something that can be interpreted. And the interpretation that matches that would be something such as, on average, the grade point average grade point average for a student who does not play video games weekly. So who does not play video games weekly is expected to be 3.457 points. So connected to all that, and then I have a third part to this question. Part C, I have here, for a student that plays video games 10 hours in a week and has a GPA of 3.60, we want to determine if this GPA is above average or below average, by how much, and interpret this answer. Right? So, to do that, we need to put 10 into our equation. So the value of y hat at the x value of 10. So negative 0.066 times 10 plus 3.457. You toss that into a calculator, and the answer you should get for that is 2.797. So you could picture it, right, with a negative slope. This line would be, for example, decreasing. And 10 hours, let's say that was like over here. The data point that this is describing would be something above here, right? So this data line would be our average line, and this point's above it, right? To find how much it's above it, this will be the absolute value of 3.60 minus 2.797. And that would give us 0.803. So the residual, or distance between the average value to what the point is, according to this, is 0.803. So to interpret this whole thing, for a student who plays video games video games 10 hours a week with a GPA of 3.60 is above average, as we said, by 0.803 points. The third question. Suppose that of 100 circuits sent to a manufacturing plant, 6 of them are defective. The plant manager randomly selects 2 and tests them. If both circuits work, she will accept the shipment. Otherwise, the shipment is rejected. And we want the probability the plant manager discovers at least 1 defective circuit and rejects the shipment. Rounded to 4 decimal points. So this is the probability of at least 1 defective circuit. So at least 1 being defective. So due to that terminology, it's best to describe that using the complement rule. 1 minus the probability that 0 of them are defective or both are not defective. But since these are dependent, not independent, we need to do this as 1 minus the probability of the first is not defective times the probability the second is not defective, given that the first is not defective. So what does that mean? This means 1 minus, for the probability of the first being not defective, that'll be 94 out of 100, times the probability of the second is not defective, given that the first is not defective, is going to be 93 over 99. Toss that into a calculator, rounded to 4 decimal places. This becomes 0.117. So the probability of at least one defective circuit is 0.117. Let me know if you have any questions or concerns. Thank you.